Have you ever wondered how solar panels are manufactured? And more to it, how you can make one from home? Today, we'll delve into exactly this, and at the end of this video, you might consider to make your own power source. But first, we explore how solar panels are manufactured on an industrial and how you can create your own at home. The journey begins with sand, specifically quartz sand. Most solar panels are made of silicon, which is the main component in natural beach sand. Silicon is abundantly available, making it the second most available element on Earth after oxygen. It's out of the quarry and into the fire. The first stage is to get the silicon out of the rocks, and that's done in this enormous furnace. Temperatures reach over 2,000 degrees Celsius. This is unbelievably hot and also quite dangerous. Silicon is used to make everything from window glass to the processes in your home computer. And without it, a solar panel just wouldn't work. The purified silicon is melted and formed into ingots, which serve as the raw material for solar wafers. These ingots are produced using either the Czochralski process or the float zone method. In the Czochralski process, a seed crystal is dipped into molten silicon and slowly withdrawn to create a cylindrical ingot. This block would be far too big to put on your roof, which is where solar panels usually go. The average roof wouldn't support it, so now it needs to be cut down to size. The silicon ingots are sliced into thin wafers using a wire saw, a process that requires precision to minimize material loss. These wafers, typically less than 200 micrometers thick, undergo surface treatment to remove any remaining impurities and defects. An anti-reflective coating is applied to the front surface of the wafer to enhance light absorption, allowing for greater efficiency in converting sunlight into electricity, and the subsequent drying process ensure optimum surface cleaning. All wafers are then measured by fully automated sensors and cameras, and graded according to their thickness and surface quality. In the next step, each wafer is processed into a solar cell capable of converting sunlight into electricity. Metal conductors, typically made of silver or aluminum, are screen printed onto the wafer to create a grid-like matrix, ensuring uniform distribution of electrical current. The wafer is then treated in a high-temperature furnace, where phosphorus is diffused into the surface to create a negative electrical charge. This, combined with the boron-doped region, forms the essential p-n junction necessary for solar cell operation. Solar panel. After this 6-year class in chemistry and physics, which we did in 3 minutes, we go to the fun part. Assemble. The solar cells are interconnected to form a solar panel, with various configurations available depending on the desired output and application. The cells are typically soldered together using conductive adhesives or laser welding, creating a series or parallel connection. Once interconnected, the cells are encapsulated within a protective layer, typically made of ethylene vinyl acetate, EVA, to ensure durability and weather resistance. A junction box containing diodes and connectors is attached to facilitate electrical connections and output. I know that was an entire college diploma. Relax. Here is the fun part now. All completed modules undergo a rigorous series of tests to ensure their durability and reliability. Beginning with an infrared camera screening, the initial test meticulously examines the modules for any micro cracks at the cell level, ensuring structural integrity from the outset. Following this, the modules undergo a flash test to gauge their performance under standard operating conditions. Next, the modules are subjected to a mechanical loading test, simulating harsh environmental conditions such as strong winds, heavy snow loads, and static pressures like ice accumulation. This test measures the module's resilience and ability to withstand extreme weather scenarios. Furthermore, modules undergo impact testing to assess their durability against heavy impacts, ensuring they can endure unforeseen incidents without compromising functionality. Innovatively, proprietary tests such as the highly accelerated stress test are employed to understand how materials and components evolve over time, providing invaluable insights into long-term performance. Additionally, infrared testing is conducted to analyze the module's temperature during operation under direct sunlight, ensuring optimal thermal management. Finally, modules are subjected to 8 distinct testing chambers to evaluate their behavior under heavy humidity, intense UV exposure, and various harsh weather conditions, including heat waves and hailstorms. Once testing and quality control are completed, packaging materials are carefully selected to provide adequate protection during transportation and storage. Solar panels are typically shipped in pallets or containers, with appropriate labeling and documentation to facilitate handling and installation. Having the knowledge on commercial panel helps this next step of your pursuit interesting. Building a DIY solar panel can be an exciting project, and with a great outline, the steps become easy. Let's break down each stage further. First, designing the layout. Assessing available space and selecting the appropriate type of solar panel are crucial initial steps. Whether you're opting for monocrystalline or polycrystalline cells, understanding your energy needs and available space helps in determining the layout. Second step is material cutting and workspace setup. Precise cutting of materials and setting up a well-organized workspace with proper lighting and ventilation are essential for safety and efficiency. Adequate airflow facilitates soldering and encapsulation processes later on. There are many ways of acquiring solar cells, mostly from platforms like eBay. Simplify the process. Ensure you select cells with a watt rating that aligns with your energy requirements and available space. The fun begins when it's time for connecting the cells. Soldering cells together to form an array requires attention to detail and proper technique. Techniques like tabbing and stringing help optimize energy production and minimize shading between cells during and after installation. Once all is done, encapsulation, which is protecting the solar cells from environmental elements, is crucial for longevity and performance. Affixing cells to a backing material and sealing panel edges with waterproofing materials like silicone shield against moisture ingress and enhance durability. Proper wiring is essential for ensuring the efficient flow of electricity generated by your solar panel. This involves connecting the solar cells in series or parallel configurations, depending on your desired voltage and current output. Finally, testing should be rigorous. Using equipment like a multimeter allows you to assess the panel's performance under various conditions. This step enables adjustments to optimize efficiency and reliability. The installation and mounting the panel should be secure, and safety should be considered when establishing a wiring connection. Once your DIY solar panel is ready, follow the wiring connections we discussed earlier to connect it to the battery bank and inverter. After making the connections, conduct thorough system testing to verify that everything is functioning as expected. This includes checking the charging process, inverter operation, and overall system performance. Finally, establish a routine for monitoring and maintaining your solar power system to ensure long-term reliability and efficiency. Regularly check battery levels, inspect wiring connections, and perform any necessary maintenance tasks. Throughout the process, detailed instructions and careful attention to each step will help you create a functional and reliable solar panel array. Experimenting and learning along the way can be part of the fun. If you enjoyed this video, here is another video that you can watch on how car body parts are manufactured. Enjoy!
This is what hundreds of millions of gamers in the world plays on. It's a GeForce.